In today's modern world filled with gadgets, the need for energy is predominant. The present world supply is dominated by fossil fuels, which are not only non-sustainable in the long term but also very highly polluting. Fossil fuels are known to be depleting, and one day in the near future, coal availability will dwindle. Technology for drilling keeps improving, but the vast reserves of oil today will also deplete soon. The earth needs a clean and green environment, and hence, new clean and renewable energy sources are desirable. And on the other hand, it is a crisis like no other. The scarcity of water in various parts of the country has set the alarm bells off in the entire country. Long winding, unending queues for water is a common sight in many states in the country. People are digging deeper and deeper as water tables go lower and lower, out of reach for mankind. Parched lands and thirsty throats are a feature everywhere as the nation comes to grips with this crisis. The issue is so serious that the Niti Aayog in its report has said that India is facing its worst water crisis in history, and the demand for potable water will outstrip supply by the year 2030 if corrective measures are not taken. And not unlike many places in India, which have been facing a major shortage in potent water and energy, is Lakshadweep and Andaman and Nicobar Islands. Due to the peculiarities associated with the location, geomorphology, rainfall patterns, and hydrogeology, the availability of fresh water and supply of electricity in the islands is limited. There are no surface water bodies such as streams and rivers in Lakshadweep. A limited quantity of groundwater is available for utilization of local population, but this water is highly polluted. The electricity and water requirement is on the rise due to the increase in population and improvement in the standard of living. The need now, therefore, is to look at different renewable sources of power like non-fossil fuel sources, which include nuclear fission, hydroelectricity, biomass, and renewable sources such as wind, solar, geothermal, and oceans. Looking towards the Indian subcontinent, it has about 7,500 kilometers of coastline with a large exclusive economic zone, EEZ, of around 2.1 million kilometers square. The EEZ is the area of coastal water and seabed associated with a country within a certain distance of a country's coastline. India also has the Lakshadweep group of islands in the Arabian Sea and Andaman and Nicobar group in the Bay of Bengal. Since the area available is large, it can be gainfully utilized to put up ocean energy devices. In the case of India, it is close to the equator and hence the sea surface is always fairly warm in Indian waters, and thus thermal gradient in India remains mostly constant throughout the year, and this can be used to harness energy called Ocean Thermal Energy Conversion or OTEC.
Global warming is being faced throughout the world, and we all know that it is essential that we should have green energy and we should not be depending on non-renewable energy sources like the fossil fuels. India being close to equator, the surface seawater temperature is quite high compared to regions which are far away from the equator. This gives us an advantage because the sunlight does not penetrate more than 50 to 100 meters, and temperatures more than a kilometers would be of the order of 4 degrees around. So what we have is the surface seawater is warm and the bottom seawater is cool, so we get a difference in temperature. This is the advantage which India has got, through which we will be able to generate power using the difference in temperature.
So, first let us understand what is ocean thermal energy conversion. It is commonly known as OTEC. Though a complex system, it is surprisingly easy to understand. A water body such as a sea or an ocean has two aspects to it: deep sea water and surface sea water. Both of these have different temperatures. For example, because the sun is directly in contact with it, the surface sea water is usually around 25 to 30 degrees Celsius. But as we go deep down in the sea, water becomes cold as it is not in direct contact with the sun rays. It is usually at around 6 to 8 degrees Celsius at 1000 meter depth. OTEC technology uses this difference in the temperatures to run a thermodynamic power cycle for generating electricity. Heat exchangers, seawater pumps and turbo generators form the major part of an OTEC system. Now, we take a look back at how the idea of OTEC was first conceived. In 1870, Jules Verne introduced the concept of OTEC in his novel 20,000 Leagues Under the Sea. But Jacques d'Assonval and his student Georges Claude were the pioneers of OTEC. Claude built the first onshore OTEC plant in 1930 in Matanzas, Cuba, which was later destroyed in a storm. In 1956, a plant was built by French scientists for Abidjan, Ivory Coast. It was made uneconomical due to cheaper sources of petroleum. In 1962, a new closed-cycle design created by J. Hilbert Anderson and James H. Anderson was rejected by the general market at that time. In 1970, Japan's Tokyo Electric Power Company successfully built and deployed a closed-cycle OTEC plant on the island of Nauru. This opened the optimistic gates of accelerated evolution in the field of producing electricity through thermal energy conversion internationally. In 1990, USA's NREL set up an experimental facility on open-cycle OTEC in Hawaii using direct contact heat exchangers. In 2000, India attempted a floating OTEC plant of 1 megawatt capacity. Though the plant equipment was readied, it could not be made operational due to issues in connecting 1 kilometer long cold water pipe to the plant. But there is more to OTEC that we need to understand. It has many different systems of generating electricity, but mainly two: closed cycle and open cycle. First, we'll see how the closed cycle system works. Closed cycle system uses fluid with a low boiling point, such as ammonia, having a boiling point around minus 33 degrees Celsius at atmospheric pressure, to power a turbine to generate electricity. Warm surface seawater is pumped through a heat exchanger to vaporize the fluid. The expanding vapor turns the turbo generator. Cold water pumped through a second heat exchanger condenses the vapor into a liquid, which is then recycled through the system. And second, we talk about how open cycle system operates. Open cycle systems use water vapor generated from warm surface water directly to make electricity. The warm seawater is first pumped into a low pressure flash chamber, which causes it to boil. The vapor, which has left its salt and other contaminants in the low pressure container, is passed through turbine generator, thus generating electricity. Then it is condensed into fresh water by exposure to cold temperatures from deep ocean water into a condenser. This method also produces desalinated fresh water suitable for drinking, irrigation or aquaculture. OTEC is still a fairly new technology to harness energy when it comes to success percentages across the world. Let us look at currently operating or soon to be operating OTEC plants over the world. Okinawa Prefecture Deep Sea Water OTEC setup in Kumejima Island, Japan in 2013. Ocean Thermal Energy Conversion Power Plant built by Makai Ocean Engineering went operational in Hawaii in August 2015. This is the first true closed-cycle OTEC plant to be connected to a US electrical grid. DCNS laboratory facility in Reunion Island in Indian Ocean. The NEMO project announced in July 2014 by DCNS Group, who have partnered with Akuo Energy. If successful, the 16 megawatt gross 10 megawatt net offshore plant will be in contention to be the largest OTEC facility to date. India's first venture in OTEC started with designing a 1 megawatt OTEC plant by National Institute of Ocean Technology under the Ministry of Earth Sciences. It was a floating plant where all the plant equipments were mounted on a 72-meter-long barge named Sagar Shakti. They included large plate heat exchangers for evaporating and cooling anhydrous ammonia, a 4-stage ammonia turbine, ammonia handling equipment and pumps for pumping voluminous quantity of surface and deep sea water. A 1 kilometer long cold water pipe made from high-density polyethylene was welded in Tuticorin port and was towed to offshore site. However, the cold water pipe could not be connected to the barge and was lost to the sea. However, the learning from this mega exercise led to studies towards using ocean thermal gradient for desalination.
As I already said that OTEC is a green technology, we have vast oceans around our subcontinent, and this ocean thermal gradient technology can be used to generate electricity as well as drinking water for the whole, especially the people who staying along the east as well as west coast. And as all of us know that we are trying to generate more green energy instead of burning coal as well as petrol. So as Government of India is committed for more green technology for producing energy in terms of solar as well as wind. So ocean energy also will be very important aspect. So we have not done much research on developing ocean energy technology. So this will be a unique technology. Once it is successful, we can generate electricity from ocean thermal gradient, and that will be very pure green technology, which will be adding to the initiatives of the Government of India for investing more in developing green technology other than using fossil fuels.
NIOT has developed an efficient system to utilize the ocean resources in an eco-friendly manner, with an objective to address the scarcity of drinking water in remote islands. It has successfully installed desalination plants based low temperature thermal desalination (LTTD) technology at Kavarati, Minikoi and Agati Islands of Lakshadweep. Desalinated water can be produced using surface condensers to turn evaporated seawater into potable water. This is done when the evaporated surface water, after losing all of its impurities and excess salt, comes into contact with the cool deep sea water and regresses to its liquid state. This is the same water, with the only difference being that it is fit to be drunk or to be used for similar consumption purposes. Today, the efforts to produce fresh water in the islands of Kavarati, Minikoi and Agati in the Union Territory of Lakshadweep have shown encouraging results. Also, the construction is in progress for setting up of desalination plants at 6 more islands in Lakshadweep, namely Androd, Amini, Kalpeni, Chitlat and Kadmat.
These plants execution has already been started, and then we are likely to complete these plants by May 2020. Once all these plants are in place, the water problem in the Lakshadweep is almost resolved. The beauty of this technology is it is environmentally friendly and easy to operate. In fact, the plants have been operated by the local islands, even they are unskilled. Once these plants have been established in Lakshadweep, the same technology can be extended into other parts of the Arabian Sea like Maldives, Mauritius and Seychelles. And it is also can be extended to other islands of Pacific Ocean.
From the time that the low temperature thermal desalination or LTTD plant has been set up in Lakshadweep in 2005, many of the problems that the locals as well as the tourists had been facing have been greatly reduced or eliminated.
One of the major issues in Lakshadweep was availability of safe drinking water. After NIOT, there is a huge shift which I have seen personally. Two things I have noticed. One, the waterborne diseases, it has come down drastically. Earlier we used to have plenty of diarrheal diseases. We used to even call it as a seasonal diarrhea. We used to have this, we used to call in our island language, we used to call jackfruit season or mango season, in which the diarrheal diseases used to come in crops. This has almost disappeared in Kavaratti. I have not seen many cases for the last few years. And another interesting point which I have noticed is the incidence of renal stones has come down also markedly. We used to have plenty of renal stones. Like every other day, you used to get a call from the hospital with a loin to groin pain, patient coming with perfuse setting, then ending up in hematuria and all. And we used to pick up stones by ultrasound. Now the incidence is coming out rapidly. When I take the history of these patients, what interesting point I asked them whether what kind of water do you drink? You drink the road water. That is the way we used to address this NIOD water. Road water, yes. I don't find 99.9% of the people who come with urinary colic are those which drink the well water.
Before 2005, we had lots of problems with the drinking water because we have only two sources, that is groundwater and rainwater. We know in Lakshadweep, in Kavaratti, we are facing the problem of drinking water because we are getting salty water from the ground. So by the coming of NIOT, the desalination plant only, gradually we reduce the problem of drinking water. Today we are getting the water for drinking by NIOT.
Before getting a desalination connection in Lakshadweep, people were faced very difficulties to get water to drink and for cooking. After getting the NIOT connections, we are getting fresh water for cooking.
NIOT's LTTD technology has now taken care of that. With the emergence of fresh drinking water, the spirits and the productivity of the island as a whole has greatly improved. As a result of these efforts, Lakshadweep is now more of a tourist attraction and can attract a rather considerable amount of revenue for the country.
NIOT आने से हमारा पीने का पानी और खाना पकाने का पानी से हमको दिक्कत थी पहले, अभी तो वो तो सॉल्व हो गई। इसलिए तो अभी ज़्यादा NIOT के ज़रिए से हम लोग हमारा ये पूरा कवरती अभी कवर हो गई है NIOT के पानी से, इसलिए तो हमारा बच्चे और हम लोग अच्छा पानी पी सकते हैं NIOT के ज़रिए से।
आई एम रसीना, मैं कवरती में रहती हूँ, हमारी दुकान है। पहले ड्रिंकिंग और कुकिंग वाटर के लिए बहुत सारी प्रॉब्लम था। NIOT आने के बाद वो फ्रेश वाटर का प्रॉब्लम है, वो सब सॉल्व हो गया।
Yes, now we are getting good fresh water for cooking and drinking. Now we are so happy.
NIOT also set up energy and desalination laboratory in NIOT campus in Pallikaranai, Chennai. Research on open cycle OTEC, closed cycle OTEC and thermal desalination is being conducted in this laboratory. All process equipment in laboratory, including the turbines for open and closed cycle OTEC, are being indigenously designed by scientists of NIOT. This test facility is equipped with state-of-the-art instrumentation and data acquisition system. The facility will prove to be an asset in development of OTEC and desalination technologies in India. The National Institute of Ocean Technology, NIOT in Chennai, has developed something that could, in fact, hold a key to the vexed problem of fresh water and energy scarcity in the years to come.
NIOT is going back to the drawing board, and we are now going to use OTEC to power desalination again in the island of Kavaratti. So the result is going to be a first ever plant which makes power from the thermal gradient in the ocean, simultaneously powering desalination, which makes it a clean and green and sustainable plant, a model for the future. In this plant, the power will be made using the open cycle of the OTEC process, wherein no ammonia or any working fluid is being used. It is just the water vapor. So this will run a turbine, and the cold water will be continuously pumped up from a very long pipe. So there are two very major challenges in this new project that NIOT is taking up. One is the indigenous development of this turbine, and the second is the deployment of an extremely long cold water pipe which has to pump very cold water from nearly 1000 meters of water depth. This combined or hybrid plant can pave the way to scaled up plants which can be offshore and which can serve the needs of the mainland. While OTEC continues to be a baseload power, combining it with desalination has advantages of power generation and water together throughout the year, and continuous supply which can be really useful for the densely populated coastal regions of India.
India's new venture of setting up this OTEC plant at Kavaratti, when successful, will put India on the grid among other thermal energy harnessing countries. It will be India's first and the world's one of only few operational OTEC plants. NIOT's experiments at the islands of Lakshadweep of providing fresh water from the salty ocean water is an indicator that in future the water woes of the country might be addressed effectively, at least along the coastline of the country. And with the potential OTEC plant setup, the energy shortage concerns will not only be solved, but also bring forth an increase in the productivity and hence the revenue of the country. We should finally be able to dream of India with its phenomenal resources, where no valuable molecule ever goes waste.